Good morning.
Morning.
I just realized I forgot to put all the stuff in the discussion topics.
All right, should we start?
Sure. Let's see. Sage, do you want to go through them or should I?
I can do it. Let's see.
Okay.
Hold on, let me find it. All right. Good morning, everyone. June 1st. All right, a couple new things. There's a pull request that moves the cache trim into the mempool thread. This thread was just periodically checking the mempool usage so that it could guide the cache trimming. And basically, we don't trim the cache until we recheck the mempool, but we don't do it every time because it's slightly expensive to check all the shards for the mempool. So we do it like 10 times a second or something like that. But this just moves the trim into that same thread, which is probably good. It doesn't seem to show a difference for now. So let's just do it. Eventually, the original thinking there was that the trimming would happen in a thread that had a hot CPU cache. So if you're sharded across multiple cores, it would be the same core that was doing the trimming as using the cache in general. I think usually that's going to be on the same core anyway. In a multi-socket system, you're on multiple OSDs. But if that's not the case, then we can always have n of these cache trim threads also. So I still think it makes sense to move it out from being a synchronous operation. So that's fine. The statifest thing, the wall clock profiling turned up. Igor fixed it. It's ready to merge. I'm just waiting for make check to pass. This inline memory is just optimizing this -0 function. It's running through testing right now. It just needs to check those results and then merge it. Let's see, a bunch of stuff merged. We can now take buffer lists and map them at runtime into a different mempool. So we can sort of account for data however we want to. We can choose to move it into the BlueStore cache pool, or we can leave it in the anonymous pool, which is to serve everything, or we can define new mempools. So there's another pull request that I think isn't listed here, but adds like 5 new mempools for BlueStore, so you can see and renames them so it's clear which ones are cache related and sort of accounted for under the BlueStore cache size. And then there are other ones that are temporary data that's just for stuff that's in flight, writes that are in flight, and deferred writes are accounted for, stuff like that. So that's great for visibility into what's going on. It's very helpful in tracking down the latest bug. There's a pull request that makes the PG temp mapping and OSD map more efficient. It uses a B tree instead of an STL map. That made a huge difference for, it's like 3 times faster and also like 3 times more memory efficient. That made a big difference on the Big Bang testing at CERN when we created a pool with like 1 million PG temp entries. let's see, JUN had some changes to the BlueStor throttling that were great, basically just eliminating a bunch of useless arithmetic, making it more efficient. Some mon cleanups from Kifu that got merged. There's an issue with the de-encoder code that the Big Bang testing turned up, where it was sort of repeatedly doing a mem copy to make a buffer that was discontiguous contiguous, but repeating it over and over again. That's all fixed. That got merged, so that's good. And Helmai had a change to the RocksDB glue that uses splice parts, which is like a IO vector or whatever scatter gather thing. Instead of having to copy it into a contiguous buffer, we could pass pointers to a set of buffers, and that went in. I don't think we ever really measured whether that makes a measurable difference, but it's sort of an obvious win, just to avoid the useless mem copy. And then there's a bunch of stuff that hasn't moved. Let's see, I don't know if any of this is super. I think the main one that is I want to look at still is this one, the unshare blobs for EC overwrite workload. I need to fix those bugs and get that merged for Luminous. I don't know if any of these other ones are sort of on a critical path. Yeah, I don't think these other ones are super important for Luminous. Yeah, that's it for the PRs. Any questions, comments?
Sage, were you going to talk about the updated ones?
Oh, I skipped them. Sorry. Okay, so there's PowerPC optimized one. It's updated and reviewed. I haven't looked at that yet. Is that ready for testing? Does it have a positive review yet?
I think it's ready for testing. I also wanted to point out, I don't know if you saw the PPC build break that happened, but so someone had changed the name of the assembly files, the suffix name from .S to .s, which caused problems for the power compilers. They basically didn't recognize it as assembly code, and it was causing build breaks. So okay. I also had to fix that one.
Is there a PR to fix that?
It's already merged. Kefu merged it. And then once that was blocking me from updating this fast zero drop. So that's all done now. It just highlights the problems we were talking about where you don't have power hardware for your CI environment.
Yep. If there's like a cloudy solution where we can get some instances, PowerPC instances in some cloud somewhere, that might be an easy way to fix that. Okay. Let's see. There's the simplified sharded work queue locking. I think we're not going to merge that because it's probably going to be slower. The callback fixes. I need to decide what path to take there. Doesn't seem to make a huge difference on performance, so I need to fix that. And the sync commit transaction, the RTC branch. I'm on the fence on that one. It's this basically is some infrastructure and tracking so that we can make a transaction commit synchronously in the submitting thread without sort of punting it to the KV sync thread. And that's only going to be good if you have a journal device that's super fast, like an NVDIMM. But we don't have any NVDIMMs. I'm not sure how many users have NVDIMMs, and I sort of need to verify those results. So I think that one's probably going to wait until after Luminous, but I think eventually we want to do that. And actually, in combination with there's a new BlueFS option that lets you make it do its writes synchronously. Instead of using AIO, it just does an ODirect PWrite and then an fsync. And that would probably, I can't remember if we turned it on. I don't know. There's certain cases where that that would definitely help. So I guess in combination with this async commit, you can basically do your whole metadata commit without doing any context switching at all, which would be a win on those. Kind of curious what that would look like on an Optane, and how many people actually have and use NVDIMS or would use NVDIMS. Okay. I think that's it. Any other comments or questions there? All right, Mark has a BlueStore update. Do you want to jump into that?
Sure. All right. So let's see. There's so much random stuff over the past week, but I guess the gist of it is that we have been revisiting a topic that has come up often in the past, where on BlueStore, as the amount of metadata on a given OSD grows, we can see a pretty dramatic slowdown. And this is something that the SanDisk guys brought up pretty regularly. There's been a number of things that have been done over the last year that have been kind of aimed at improving this. But until we had kind of a good way of actually doing wall clock profiles in the OSD, I think a lot of it was just kind of semi-informed or kind of educated guesses as to what to look at. So we've got some more information on it now. Basically, what happens is once you no longer have O-nodes in cache, you end up doing a lot of work in the TP OSD TP threads inside an area of code where the PG lock is held. And for a variety of reasons, both in terms of the just CPU overhead and doing reads in the RocksDB database to look up O-nodes and extents, and then also holding that PG lock, there's a pretty dramatic slowdown when O-nodes are not in cache. It can be upwards of maybe 3 or even 3.5x. So in the past week, there's been a couple of things that help this. One is that we were seeing a lot of work being done in trim inside areas of code where the PG lock is held in the TP-OSD TP threads. So there's this PR that Sage had mentioned, 15.380, where basically that's now being done in a separate thread. And that does help. PG lock contention is down. CPU usage looks like it's down in general, not just within that block of code, but in general, it looks like we're spending a lot less time in trim now. So that's good. But it unfortunately, performance hasn't really improved dramatically. It's a little bit, but not that much. And it seems to be because we are still spending a whole lot of time doing reads in RocksDB. So right now, at least, it looks like kind of the way around this is basically just making the caches big. So if you've got like a large NVMe drive where your OSDs are maybe 1 or 2 terabyte NVMe drives, to get kind of the current high level of performance that BlueStore can do, which at least on the drives I've got is somewhere around like maybe 37,000 write IOPS. You need a big cache to do it. So I was seeing for a 512 gigabytes. Now, granted, this is when the OSDs we had some issues where the BlueStore was leaking memory that have been fixed now, so I need to go back and look at this again. But maybe 4 gigabytes, maybe even 4 gigabytes or maybe even 6 gigabytes of O-node cache to maintain 30,000 IOPS for writes with this. Looks like BlueStore is going to be very, very memory and cache hungry to kind of sustain that kind of performance on a very large NVMe drive for OSD. Smaller ones don't require as much cache, or if you have less O nodes and less extents, that might also be a reason for probably keeping the min-alloc size bigger. But anyway, there's a lot of moving pieces here, so lots of things to still look into, especially now that we no longer have the memory leaks that we had previously. So I will probably be spending more time this week looking into this. I think the only other thing to mention here is that we do definitely see, especially when we are doing lots and lots of work in RocksDB, that comparison operators are taking a lot of wall clock time. And I think Igor was hoping that he might be able to figure out some not horrible improvements to make this better. But I don't know if he's here. But so far, kind of the gist of it was that nothing. Oh yeah, Igor, you're here. So do you want to talk about what you've seen there so far?
No, let me have some more time for investigation.
Okay.
Maybe later.
Well, maybe the very high level is that we're spending a lot of time there. So if we can figure out ways to make that better, it will probably pay off. So that's what I've got this week. Any questions on any of that?
I have a question. Does anybody plan to use NVDIMS?
Oh, we don't actually. This James, we are planning to use Optane.
Optane. Okay. We need to get some of those so that we can actually test with them. Is anybody from Intel here? Anybody want to send us some Optanes? Because yeah, that would be.
Oh, Sergio, we're going to test probably next week, so we're going to have a report soon. Okay, we can share.
That'd be great.
You.
Okay.
We have a concept of Optane drive in house. We're going to test this week. This coming week.
Awesome. Sounds great. Okay.
Sage, what I worry a little bit about those, even if we stick like RocksDB on Optanes, that RocksDB is going to be doing a lot of work that we don't do in the caches.
It's going to be doing a lot of work that we don't do in the caches.
So like right now, what we see, or what I'm seeing when we have a small cache where all of the O nodes don't fit into it, right? We've got lots of writes and lots of reads happening to the RocksDB database at once. So they're contending with each other, and there's all this stuff going on. So even if we stick faster backends behind it, I mean, it might help some, but I'm not sure if it's going to help enough.
Yep.
Without us going in and
I think the only sort of good news is that there's some knobs we can turn to sort of trade I/O for CPU. So if we shrink the write buffer size, for example, that'll make the key comparisons much more efficient, but it'll mean more background compaction.
Actually, that's what I'm trying to do at the moment to reduce the mem table size.
Oh, cool. Okay. Yeah, I have a feeling that we're going to want to do that. But
yeah, we just have to balance out the right.
Yep. Right. And there's somebody looking at the RocksDB change, some RocksDB L0 compaction changes that'll prevent our wall deferred writes from leaking into the L0 files. So that'll help too.
Who's working on that, Sage? Do you know?
It's a girl from Intel, Lisa. Don't remember the family name.
Yeah, someone on Tushar's team. Yep. So that's exciting. Looking forward to that. I'm guessing it's going to be sort of it'll be like a format change. It'll be the compatibility issue on the RocksDB side is going to be tricky if you enable this and whatever. But we can always fork and do what we need to do. So we'll see.
James?
Yes.
Yeah, we got a little bit of problem regarding to asynchronous messenger. So last 2 weeks we have we run the pressure test in one of our Ceph cluster, and we run 24 hours heavy node heavy workload against one of our cluster. We have basically we use a container. We have like 1,280 clients within container to access their one of our Ceph cluster. The Ceph cluster was organized with 20 servers. Each server has 12 OSD against one SATA SSD. And we run 24 hours. In the first 12 hours is pretty good, but once come to a certain point, the CPU peak and the memory was used. We basically each server has a 128 gig memory. The memory is okay, but CPU come to the peak. Then we see their OSD crashed, OSD down, and as OSD was marked down just because the heartbeat has no reply. And the heartbeat once heartbeat time out, and the OSD was marked down. Apparently, was voted by 3 other neighboring OSDs. And then of course the OSD get recover. OSD later on was bring in and do the recovery, and it has a big impact to the kind IOPS. And we do lots of analysis in last 2 weeks. We found out one of the workers in asynchronous messenger actually get timeout. And I'm not sure whether in the Ceph community have ever got this problem before with asynchronous messenger with heavy workload.
I don't think we've seen it, but do you have like core dumps? Do you know where it got stuck? Did it get stuck in the messenger code, or is it a fast dispatch related deadlock or something? Or do you know?
Well, we've already put some because this is in our production cluster. We pretty much turn out lots of logs over there. So we recently created new logs in one of their Ceph release, and we put into the testing cluster. So soon we're going to have logs.
Okay.
Let's see how to. But right now it looks like it's a box of asynchronous messenger. Once the CPU gets very high, and one of the workers get timeout, and they cannot receive any of the heartbeat message, the heartbeat message then timeout.
I see.
And the OSD will put down.
Okay.
So we will give you an update once we have more, their logs to prove that this is what we observed.
Sounds good. Okay. There have been several fixes that have gone into async messenger in the last 2 weeks. Not fixes, but changes to change the locking around the right stuff. And there's a bug fix related to that.
We saw it. We also right now try to experiment with our cluster. We saw the checking by the Hotmail, right?
Yeah.
Yeah, we saw it.
Okay, cool. Okay, well, definitely curious to hear what you find out. We haven't seen it, so.
Yeah. But as I mentioned, next week we are start to experimenting Opton drive with a Blue Store, and let's see how the performance goes. In the meantime, we also has a code stream, the memory cross point in our house. We're going to test too after we done with a cross point.
Okay. Sounds great.
Cool.
Okay.
Hi, Sage. Quick question.
Hey.
Blue Star, has any work been done around sort of large disks? Like, if you've say got 8-10 terabyte disks and they're 70% full in terms of sort of the DB partition size requirements, memory requirements. Has anyone sort of tested up to those sort of limits?
I filled up a 6 terabyte disk.
Right.
But haven't done a whole lot of work at that point.
Okay.
Yeah, I have a full 6 terabyte disk right now I can play with, and I have a couple 12 terabyte drives.
Okay.
I haven't plugged in yet.
What was the standard DB partition? Was that big enough and stuff, or is there any sort of special?
I didn't look. I mean, it doesn't really matter because the Blue Store will just if the fast stuff gets full, it'll just spill over onto the slow stuff. So if your DB partition is too small, it's just not as fast. That's all.
I mean, is that sort of similar to the moment with file store when like your VFS cache effectively runs out and then it takes a lot longer to look up records? Is that sort of similar when your DB overflows? Yeah.
Yeah.
Okay.
Yeah. Basically, if it wants to write and the DB partition is full, it'll just write on the big device instead. So it gracefully degrades. And RocksDB knows the size of the devices, so it in theory is putting the colder SST files on the slow storage. I have no idea how smart or how well that works, but yeah. But I think what we really want to do is basically just fill up the device with whatever your sort of workload is, and just get a sense of how big the metadata is, so that we know. So if it's an RGW workload, you're going to have less metadata because it's going to be like bigger objects, and they're going to be written sequentially. If it's an RBD workload, depending on your workload, it's probably going to be more fragmented. You're going to have more blobs, more metadata, more fragmented, and so you'll need a bigger device. But don't have a good sense of what those sort of ratios are right now.
Okay.
I suspect too. I was just going to say, from a performance perspective, if you've got some kind of SSD or NVMe drive for your Debian wall for spinning disks, I don't think you can write fast enough, do small random writes on a spinning disk fast enough that's probably going to become a major bottleneck the way it is on NVMe. And you're just trying to make write out IOPS as fast as possible to the underlying device. I think the scary test that probably one of us should do, maybe I'll try to do this, is make like a big LVM device out of like 4 NVMe drives that's 4 gigabytes or 4 terabytes or something, and just see how bad it gets. That's kind of the thing that scares me, is when the RocksDB is no faster than the underlying device and you're trying to do write IOPS as fast as possible.
Okay. So I mean, just to give example, so at the moment with file store, we've got large 6 or 8 terabyte disks, and they're sort of full with pretty much static data, but then suddenly just a random section of that will then become very active. And you do see a massive impact between if something's in the file store cache or not. So I was just sort of curious if it doesn't sound like there's any ratios you've got yet, but there might be something I can try and look into at some point.
Yeah, I think our problems in BlueStore are going to be different than FileStore, right? Because in FileStore, if you've got a really full 6 terabyte drive, you probably have lots of objects, which means you've probably descended into multiple different subdirectories within the PG directory, and you've got different objects in different AGs in each subdirectory because of the way that it's grown. So the directory itself is fragmented all over the place. So any kind of inode lookups are going to be random seeks, and any kind of you also are doing all the directory lookups just to get down into that subdirectory, and a limited amount of inode cache and de-entry cache. And then on top of it, if you're running SE Linux, which hopefully not, but then potentially you're doing like inode lookups for any kind of security X adders too. It's just the whole thing gets really, really nasty. So BlueStore doesn't suffer from all of that, but you've got other things in BlueStore that you have to worry about. So it'll be different, but maybe there will be things that we'll need to look at, just different things.
Yeah, okay, it's interesting. I mean, it was sort of, I guess, slightly following on from that post I did on the mailing list about the sort of different type of SSDs coming in now, is that you can't get small, high write endurance ones anymore, and sort of what does that mean for sort of picking the next generation of your hardware? But I guess it's something interesting to look into.
Yeah, the write amp in RocksDB is kind of scary from that regard, right? Because you've got all these levels and everything's moving around all the time. So if we can't get smaller high endurance drives as easily, that's something that, I don't know, a little scary. But maybe it's all going to go to NVRAM or NVDIMMs, right? Maybe
Well,
that's the future.
That could be it. I mean, 'cause it's looking like a lot of the PCIe NVMEs now, that the smallest high write endurance ones you can get are going to be like sort of 2 terabytes, you know, which still aren't cheap. So it's sort of a question about, you know, where everyone's had these sort of 400 gig high write endurance over the last few years, that's sort of not available anymore.
Sage, you were grinning.
Yeah. I bought a big NVMe the other day, and it was like super expensive. That's all. They're not cheap.
Yeah. So Nick, I vaguely remember that thread. Was there something from? I know that the concern was that Intel drives are kind of going away from that. Was there some other brand that someone had mentioned that kind of still was that way?
I think that might just be short term. I mean, it just seems the general landscape is that everyone's going with the 3D NAND. So, like, you know, capacity goes up massive and write endurance drops. But I think outside of, you know, niche sort of you know, environments, everybody just wants bigger SSDs generally. So I don't think there's that demand for it.
Mm-hmm. Well, I guess on the plus side, if you could just buy a giant drive and you're spreading your writes over more cells, so even though the endurance of each cell is lower, if they get cheap enough, maybe it's more or less the same thing.
Yeah, I mean, at the moment, I mean, it might come down in price. It was looking almost like sort of 4 times the cost for the smallest sort of new lot, which isn't you know, puts up the price quite a bit, but. Yeah, I mean, I guess the other option is maybe the RAID controllers start coming back into the, you know, I know that whole idea of Ceph was trying to get away from them, but do they start to become more attractive again? I don't know.
Yeah, or we try to find stuff that has less write amp, like software key value stores that have less write amp.
Mm.
Hi, Saj. I got another question for you. So we have been discussed about you know, write 3 copies and return 2, and through one of their PR we submit, and we exchange ideas several times in that PR, and of course we do lots of our own diligent work in our side, and we do find some bugs with the previous PR. Right now, we fix some problem in terms of data lost during the remapping, PG remapping. So we fix it. Right now, we rerun lots of you know, internal tests, and I was wondering whether it's still okay to propose a new PR into the community so we can discuss.
It's very complicated. There are a lot of assumptions in the way that the peering code works, that we only need to basically look at one replica for any given past interval to be sure that we've seen all the writes that were backed to the client. And if you change that threshold, then you say, oh, suddenly you have to look at 2 out of 3 of the clients to know that we've seen the write, whatever. So it gets, in theory, it's possible to do that. I'm hesitant to complicate the peering to make that a tunable threshold. With it as part of the standard replicated PG code. I don't know. I mean, if we can come up with a well abstracted, well described, well motivated, theoretically motivated approach, similar to the way we deal with min size, for example, then I think we need to consider it. But it's hard. So it's sort of the trivial thing where you're just like, oh, 2 out of 3, I'll not send the ACK or whatever else send the ACK, isn't going to work. Like it needs to be more complicated than that. So I guess, I mean, submit the PR and we'll look at it. But just like, be warned that in order to do it correctly, we need to sort of have a high degree of confidence that that is theoretically correct. And in order to merge it, we need to know that it's not going to be too complicated to maintain. So we need to sort of understand exactly what the implications are, document it well, and then like have testing and have confidence that we'll be able to support it. Because it's already complicated code. We don't want to sort of add a bunch of stuff that's sort of not.
I totally understand.
Right. Yeah.
That's the reason why it's so complicated. We don't have strong confidence enough to say, hey,
yeah,
we try several. Pretty much we almost run one month test. Rigorous test. We found several bugs and we fix them and we rerun the test. But we still have frankly, we don't have strong confidence. But the benefits is so huge, especially for our own applications, especially for online. That's the reason we keep on pushing. But just because our application uses these kind of features.
So I guess my question is, what is the use case here? Does it need to be something like, is it RBD, or is it something that's using Liberatus directly?
It's an RBD. I tell you right now, with certain of our application, we run rigorous tests, and a certain 4.9 latency is almost huge. It's huge. It's 2 seconds. It's totally unacceptable to us. That's the reason why we keep on.
Yeah. Okay. Well, I think I think it can be done. It's going to be hard, I guess, as Greg has pointed out, right? So,
I know
the model is different than HDFS. HDFS has a write 3 and return 2, and they're going to deal with the tail latency. But the model is a little bit different. The model is different. I totally understand. But because we push, and we also need looking for your advice for sure, because you are the to learn to know.
I think the other thing to keep in mind is that there is a trade-off, right? So the way that the recovery works now, we know that if there is a previous interval, where an interval being a time span where there is a certain set of OSDs replicating a particular PG, as long as we can reach a single OSD out of that previous interval, and we know that we'll be able to discover any writes that happened during that interval. And so that means that out of the 3 OSDs that were hopefully there, then as long as you can talk to one of them, then you have that write. If you change this to be a 2 out of 3 type of thing, then you have to talk to 2 out of those 3 OSDs in order to get the write. So you're trading tail latency for reliability.
Yes.
Right?
Yes.
If you lose 2 OSDs, you have no idea if you've seen all the writes or not.
Totally. Yeah.
So you might want to
doesn't seem to me like this is the right direction to solve this problem. I mean, you'll reduce the frequency of these latency excursions, but you're not going to eliminate them. If the problem is that a 2-second latency is unacceptable, you're going to have to throttle the individual OSDs to keep it below that. Okay, just changing the recovery.
That's not our solution. Okay? We know and this is not a solution to throttling. Okay, we have as I said again, one of our cluster has 10,000 clients, and you have no QoS right now to control each clients, and there's no way to just throttling either networking or disk to do it. Frankly, to say sorry, sorry for interrupt. I know my application very well.
Well, I understand what you're saying. All I'm saying is if you're running a pattern right now and you're seeing a 2-second tail latency, let's say it's 5 nines, and you change
It's 4.9 right now, 2 seconds.
Whatever the number is, what I'm saying is if you change the recovery model, you will change the number of nines to the better, but you won't get rid of the fact that your worst case latency is still going to be 2 seconds. It'll just be happening significantly less often.
Mm-hmm.
First of all, I didn't catch what you said very well, but I just tell you what we want. The application or the computing side or client, whatever you call it, normally right now it's a MySQL instance running on Docker. The MySQL normally has stringent requirement towards the tail latency. If any of the latency, for example, right now we set up as 20 milliseconds. If any of the requests against MySQL instance then go to their Ceph cluster more than 20 milliseconds, the front request is going to fail. The request is pretty much come from the e-commerce or PayPal, or not PayPal. The e-payment.
I understand, and this is not an unusual environment. I'm just saying that the change that you propose is very difficult and actually won't fix the problem.
It does. As I said, this is the reason why I said it does. As long as we can guarantee their data consistency, that's fine. I can guarantee you solve our problem.
It depends on your definition of fixing the problem. If your definition of fixing it is meaning a better SLA, then it's fixed, right?
Yeah.
It's not going to give you a perfect SLA, but I'm not sure anything will.
Yeah.
Because you have, hardware failures and you have whatever, you have all kinds of other things to contend with.
Yeah.
Yeah.
So we definitely one more week we run the test against what we fixed so far. In one more week, then we're going to submit one new PR. Then we probably, as I ask for your advice again.
Okay.
Because that's not only push it to their Ceph community. It's really about our own application because we need to make sure data is safe.
So just speaking broadly, I think there's sort of two ways to address this. The first way is to take replicated PG and make it more complicated, which is sort of a dangerous road to continue pushing down. But it would solve or improve the situation in the general case for RBD and CephFS and everybody else who uses sort of the standard replicated pool semantics. The other way to go is to look at ways to structure a distributed object store that sort of don't have all the complexity that you have with sort of the very general data model that the current pools provide, where you have arbitrary objects and they're all completely mutable and you can name them whatever you want and you can delete them and you can replace them, whatever. If you sort of constrain those semantics where, objects are immutable and they have unique names, then you can vastly simplify all of the recovery logic and the replication logic and the update logic so that you can do things like, 2 out of 3 acts is okay. But if you simplify the semantics, you can do something that's much easier to reason about, sort of prove is correct, and solves the latency issue. This is something that we were talking to Salesforce.com about, I guess a year and a half ago or something like that. And that would mean implementing a new type of PG that sort of has these different recovery and update semantics, basically. And that's like a much lower risk and less disruptive path to go down. It doesn't solve it for your case because you're running MySQL, which needs sort of a generalized block device. But for lots of sort of big applications that are latency sensitive, that can afford to sort of write directly to Librados, it would make sense. So
yeah, we also have a team with Salesforce guy team, and they got some similar problem as us.
Yep.
Yeah. Okay, definitely we will do more tests and submit a new PR and ask for your advice. Okay. I totally understand the complexity, and we don't have confidence so far, frankly, and we need your advice.
Okay.
And one more issue, 2 weeks ago, and one of our guys actually submitted synchronized, their submit. in the Blue Store. Do you remember that was submitted by the Shen Qiu? They talked with you.
Oh, yeah.
What's your
Yeah,
opinion? Because at that moment, I was interested in travel.
I can't remember. I'm gonna have to go look at it again.
I'm gonna send you again, okay? Because right now we also do lots of tests. So far it's okay, and we need your advice to see whether we should push it to the
Okay.
or not.
I just want to throw out one other thing here. If your end goal is to run MySQL, another possible path here, and there are obviously like 10 things you need to be worked out in order to determine whether this is viable. But MySQL has the new RocksDB backend, and you can back RocksDB directly on Liberados. The reason why that's interesting is that the RocksDB write pattern is writing data once immutably, and so you could probably design a placement group with much simpler update semantics, where objects can only be appended to or created or whatever. They're never modified in place. And you could make something that does sort of 2 out of 3 or whatever, 2 out of n, n out of m, whatever update semantics that we could have confidence with without sort of risking destabilizing sort of the existing replication code.
Oh, you mean that MyRocks?
Yeah, MyRocks. Yep. Yeah, but still be able to. Yeah.
We checked the code 6 months ago. We already do it. Do some experiment with MyRocks. We have also talked with the Facebook teams about MyRocks.
You have lots of what teams?
We have lots of talk with Facebook team.
Oh, cool. Okay. Okay.
Yeah.
Okay.
Thank you.
Yep. Okay. Yeah. Just so you're aware, there's also in RocksDB there's a Liberados backend, so you can take RocksDB and back it directly with Liberados.
But Serge, I just let you know right now we already have a 3 cluster running MySQL against the cluster directly. So that's the reason why I got to push, man.
Yeah.
I already have a 3 production cluster running now.
I know. Okay.
Okay, thank you.
Right. Cool.
Sage, I had a hopefully easier logistical question. Hopefully this isn't the wrong place to bring it up, but right now when you enable BlueStore, so you had mentioned that it's going to be the default, is that right, in Luminance?
Yeah. Mm-hmm.
So does that mean at some point you're going to take out the enable data corrupting feature?
That's already gone. That's already gone, actually. Yeah. So the next switch is just to make sure that Ceph disk takes both a -- file store and a -- BlueStore argument, and that the default is BlueStore.
Great.
And that PR is there, just that it's not passing tests right now. There are a bunch of unit tests that need to be fixed, but that's it.
Got it.
Cool.
Okay,
All right. Thanks, everyone. Have a good rest of the week. And I'll see you next Wednesday is the developer call. It is, I can't remember if I think it's European time. I can't remember. But hopefully see you.
That's on Wednesdays, right?
Yeah, it's the first Wednesday every month.
Okay, so we'll still have this meeting on Thursday.
On Thursday, yep.
Yeah, cool.
All right. See you guys.
Talk to you later, guys.
Thanks. Bye.